When we left off, we'd wired, configured, tuned this car, had it on the dyno, made some good power, but this is a serious race car, and a serious race car needs serious race car testing. What better place to put pedal to the metal, put some tires down, make some smoke, make some noise, other than a real racetrack. This is Brian. This is a guy that owns this beautiful R35 and has done some pretty crazy work to it. So mate, this is not a car that you sort of normally see like this. Can you tell us a little bit about the backstory behind this car? Like, where'd it come from?
So originally I found this car for sale in Queensland, just for sale on Skylines Australia. It is actually the ex-Q-Scan Mercury Motorsport car. It was a rolling shell, bare, nothing in it. It had obviously been parted out. I picked it up just wanting it for parts originally, and then decided when I picked it up that I was going to turn it into a full-bore race car and get rid of me road R35 GTR.
So tell us a bit about the combo in this and why you chose to set it up like this.
Wanted to get rid of the four-wheel drive, so it is a full-time rear-wheel drive car, and that's more for the reliability and cost factor. Always wanted a sequential, so just put the gearbox straight behind the engine, and here we have it, GT3 spec type car.
And she's away, and mate, it's something, this has definitely reignited my passion in the time attack, in the circuit racing style, because I'm with you. I fully get it that having a car like this, that the engine's capable of making huge power, sequential gearbox, no complicated rear end, and it's going to take driver skill to get this thing around the track.
Yep, and that's what I'm going to enjoy. It's going to be a lot of fun.
So how long you own this thing?
Just over 3 years now.
You ever driven it?
Just around the pits here, and I want to get out on track.
All right, so it's time to get this thing shaken down. Brian can do some laps, we can see what's going on. This is going to be a cracking day. So the plan for today, first and foremost, is to shake this car down. And what we mean by that is to get it out on track, do a few laps. Because there's been so much work done on this car, we want to make sure that everything's tight, nothing rattles, nothing falls off, we don't have any oil leaks or anything like that. It's always assumed that you do so much work on a car, there's always going to be something that's been missed. After that, we'll come in, we'll look at all of the engine diagnostics, make sure everything's looking good. Then we'll go through and we'll set up all the features and functions in this car. So the things that we're going to be setting up today are the wheel speed based traction control, as well as configuring the ABS to be sending all the data into the ECU so that we can pick up all those wheel speed sensors and the G meter that's in that unit. Before we do any of that, I'm going to set up the onboard data logging in the Nexus ECU. It's capable of 300 channels, each channel 1,000 times a second. So I'm going to sit down, take my time configuring all of those channels so that when it goes out on track, I've got the right data when it comes back. Well, this is my office for today, and I'm really excited about it because it's the first time I've been able to take full advantage of the Nexus series Wi-Fi communications. I'm sitting here under the shade, the car's down there, the ignition's on, which means that the Wi-Fi comms is on, so I'm communicating it from here. I'm going to sit down, I'm relaxing to set up the data logging. This is something that I don't want to rush because I've got to choose over 300 channels, so all of the sensors and all of the engine operating parameters coming in so that on the shakedown lap, I've got enough information when it comes back to know that things are operating correctly. The channels that are going to be most important for me today are our engine health channels. So all of our temperatures, all of our pressures, our gearbox temperatures, super important, as well as things like our battery voltage and sort of general health of the car. The next things that are going to be logging are our wheel speeds and all of our G sensor stuff so that I know sort of what's happening there, as well as our fuel pressures, our injector duty cycle, our ignition angle, our manifold pressure, our throttle blade angles versus our throttle pedal position. I'm going to go through, I've got 300 channels to pick from. I'm going to go through and get all of my most important ones in first. Then when I've got room for those extra ones, I'll add all that rest of the stuff in. You can never have too much data. So I'm going to enter that all in now while I'm relaxing here. I'm not sort of cramped up in the car. We've got to set our sample rate. So we can set up to 1,000 samples per second per channel. I'm not going to set it like that just for this shakedown pass. I'll probably do about 100 samples per second. Then after I've got that data in and I've got something that I really want to narrow down on, I'll pick those channels at 1000 Hertz. Data logging in the Nexus series ECU is pretty straightforward. We go to our logging up the top here, data log manager. Once that opens up, we've now got our list of channels that are already selected. If I go to add remove, I can add and remove any of the channels that the ECU has. Then it asks me what sample rate I want for those channels. Then, as soon as we press apply, starts logging to the onboard memory. The ECU's got 512 megabytes of onboard data logging. It's always logging and it's loop logging, so that when that log fills up, it'll get rid of the oldest log and just keep on going with the newest data. If you've got an Elite Series ECU, we recently did a tutorial on how to set up the data logging using the ESP software, so we'll put that in the links below. Have a bit of a look at that if you've got an Elite Series ECU. So Brian's job on these initial laps is to go slow and watch out for things going wrong. Remember, this is Brian's first time on this track and first time in this car. A quick mechanical check and Brian's out again, going a little bit faster and collecting a little bit more data for me. Oh, all right, well that's good. No fire, no smoke, no spills. The thing made it a few laps. So now we've got to go through the data, see what happened. Pulled the data log out of the ECU via Wi-Fi. Now it's just loading into our data log viewer. I'm going to go through, have a bit of a look at our engine RPM, our oil pressure, our coolant pressure, our coolant temperature, our gearbox temperatures. Just make sure that everything sort of looked right. Just go through and just check absolutely everything before we move on to the next part of the day. So the first thing I'm going to look at here, our minimum and maximum manifold pressures. So we had a maximum of 14 pounds or about 1 bar or 100 kPa of boost pressure because we're running the thing at the lowest power level we possibly can. RPM, Brian revved it to a total maximum of 69.58 or nearly 7,000 RPM. I'm just having a look through now to look at some mixtures, have a bit of a look at the PDM side of the ECU, so looking at the current outputs to make sure that nothing's gone over current or no sort of virtual fuses have blown. Then we'll go through some battery voltage stuff, just make sure, basically just doing a good health check. One of the things that I do look at for here is, so this is up the top, we've got the entire length of that shakedown, which was about 4 minutes and 40 seconds, something like that. And then the last little bit of the log there is a little bit of a cool down. If I look at the trend of things, that's probably more what I'm interested in rather than individual values, which we would narrow in on if we see a funny trend. But if I look at something like battery voltage, for instance, pretty flat, it didn't roll over towards the end, we didn't get any huge spikes, nothing bizarre like that, so I can rule that out. The next thing that always worries me is engine oil pressure. So if I cruise on down, I'm just going to find oil pressure. We'll click on that, and I'm just going to pick on a few little points of the log where there's some good revs in it. And if I look into here, and I can see that as the RPM increases, the oil pressure increases. So at the beginning, 4,500 RPM, 88 pounds of oil pressure. If I come down the back here, as the oil's warmed up a little bit, we're at sort of about 60 or 65 pounds of oil pressure at about 6,000 RPM. So things are looking pretty good there. There's no obvious dropouts or anything like that. We'll pick up oil temperature and see how that's sort of trending. So at the beginning of that sort of shakedown, it was about 75 degrees Celsius. By the end, 97 degrees Celsius. And that's the reason for that oil pressure rolling over as that oil temperature comes up. Makes sense. Coolant temperature, because this thing's got so many coolers in the front of it, it's got trans coolers, it's got oil coolers, it's got intercoolers, so we need to check that we're getting enough air into the actual cooling system, so into the radiator itself. So if you look at the trend more so of that coolant temp, fantastic. So we warmed it up before we took it out, so it started at about 80 degrees Celsius. By the end, 86 degrees Celsius, and we can actually see that thermostat going up, going down, going up, going down. So fantastic. So nothing to worry about there. We'll go through, we'll have a look at our mixtures, we'll have a look at how our O2 sensor corrections are doing, so they'll be adjusting our fueling as the thing's out on track. At the moment, things are looking pretty good. I'm pretty excited about how the data's looking for the first laps. Here's something a little bit interesting. One of the things that we've picked up in the data is that we've got our 4 wheel speed sensors coming into the Haltech ECU. Well, actually, they're not coming into the Haltech ECU in this particular case. Normally, they would be wired into any of our digital inputs. In this case, the 4 wheel speed sensors are going into the Bosch ABS unit, then out of the Bosch ABS via CAN into the Nexus ECU. I'm looking at that data here, and I can see that 3 of the wheel speed sensors are doing pretty much what I would expect them to do. So because they're relatively soft laps, I don't expect us to be seeing any wheel slip or anything funny like that. What I can see here in the log, the rear left, as Brian's giving it a bit of a hit, is spinning way faster. So in this particular case, 150 k's an hour on the rear left, whereas the rear right, 90 k's an hour. Some of the guys here were watching the car and saw smoke coming off that side of the car. So what I surmise from this is that the diff in this car should have a limited slip in the back. We'll talk to Brian and figure out what's going on, but it looks like one rear wheel is spinning a whole lot faster than the other. In order to set up traction control, I'm just going to open the NSP software. I'll type up the top here, traction, there we go, traction control. I'll right click on that, enable traction control. So we do have to fill in a couple of details here about where we want to get our wheel speed sensors from. So they're coming in from the ABS unit. It asks us about what we want it to happen. So in our case, I want to cut ignition, and that's the fastest way to drop the engine power, so we reduce that spinning wheel. Our ramp out rate, meaning once it does cut, how fast we want to reintroduce that power. So we've got a couple of options here, which is soft, moderate, aggressive, or none. If you're not too sure, always nice to go in the middle. We'll select moderate. Then the table that's important is our desired slip table. What this is doing is asking us basically how much slip we want between the front wheels and the rear wheels. So I might want to say, okay, I'll allow the rear wheels or the driven wheels to slip 10%, 15%, 20% more than the front. If it's any more than that, reduce engine power. We'll map that versus road speed and versus gear. The next thing that we want to test while we're at the track day is the pit speed limiter. So this is really important. As you come into the pits, we want to be able to press a button to limit the speed. First of all, it's for safety. Second of all, if you are at a race event and you do get pinned going through the pits too fast, it's embarrassing, it's rude, you can lose points. So best to limit that speed when you come in. So if we come across to here, gonna go through, we'll search for our speed limiter here. Okay, so we're using one of the keypad buttons to enable this. So as Brian comes through into the pits, he'll press that button, it'll latch on, and then that speed limit will be locked at 50 kilometers an hour. In this area, I might drop that down a little bit. We might go to 40 kilometers an hour. To be honest, I don't actually know what the speed limit through this pit lane is because we're here on a private test day. So 40 k's an hour is going to be the number for today. We're going to cut ignition. So what that means is that no matter what throttle Brian puts into it, the car will only come up to 40 kilometers an hour and then kill all engine power. So I expect it to come along coughing and spluttering. I'm going to get him to drive the whole way through the pits on that speed limiter. Then on the exit, I'm going to get him to press that button. It'll regain power and he'll take off again. We can set this up so that the driver can have it as a momentary style button, meaning you hold that button down and whenever you're holding it down, that's the speed that you're set to, or as a toggle style, so a flick on, flick off. It's all up to what the driver's used to. One of the things that I know Brian wants to test today is the Bosch Motorsport ABS system. So we've got that integrated with the Haltech ECU via CAN. If I cruise down here under connections, then CAN connections, vehicle CAN. I've got here Bosch Motorsport. It's communicating at 1 megabit on that CAN network. And the data coming in from that Bosch system, I'm just going to read it straight off the settings here. Our 4 wheel speed sensors. We've got our brake pedal switch. We've got a brake pressure sensor for the front, a brake pressure sensor for the rear. We've got our ABS trim knob. So that's one of those, a mechanical style rotary knob that's actually in the dash, and that's giving the ABS system what setting or what map it's going to be on. So we can bring that into the Haltech ECU and then we can limit power according to how the drivers set up their Bosch ABS system. It also brings in a yaw rate sensor, a roll rate sensor, a lateral G, a longitudinal G, and a vertical G sensor. This is one of the very few cars that I've worked on that has a 6-axis G meter in the Bosch ABS system, but also has a 6-axis G meter in the engine management system. Very rare to have one 6-axis G meter, let alone 2. I've gone through the data log from earlier and I've gone through and made sure that all of our pressures, all of our sensors are coming through from the ABS, so that communications network's working brilliantly. We've got our ABS status values. So that's a channel that the Bosch ABS sends to the Haltech. We can then broadcast across to the dash to give you any error reports, let you know the ABS is working, let you know that the mechanical ABS switch is turned off, so it's disabled, give you all of that sort of error reporting stuff as well. Because Dave Bryan's shaking the car down today, he's going to give those brakes a few hits. I don't know how much he's going to get that ABS dialed in today because we're more here to set the car up and make sure that the thing's going to do lap after lap. Brian, the traction control's disabled at the moment. Can you just give it some beans coming around onto that last corner so we can see what happens?
Copy that.
Righto mate, so let's turn on the traction control. Just press that button once, it'll latch on and then go do the same thing again.
Copy that.
That looked a whole lot cleaner from this angle. How did it feel in there?
Oh, that's really cool. Definitely got some more confidence in it now.
All right, beautiful. That and a combination of ABS, how could we go wrong? Mate, I can see you having a ton of fun out there, but you got to come in, we've got a little bit more testing to do. I want you to press the pit lane speed limiter button, come in, go through the pits on the limiter, then exit, turn the speed limiter off, and then recirculate.
Copy that. Certainly having a lot of fun out here at the moment. I'll come in next lap.
With the track all to ourselves, the time flew by, and as Brian put in lap after lap after lap, our day was drawing to an end. The light was disappearing quick, and the sunset caught us almost by surprise. But we got what we came for. We could have kept going forever, but the important thing was that we've achieved our goal, and that was to perform a solid shakedown, which couldn't have gone more perfectly.
Well guys, it's been a hell of a series, it's been a hell of an adventure. This has been a build series that I've personally really enjoyed. I love this car, I love this style of racing, and I'm looking forward to doing so much more of it. I know, just like the Falcon series, there's going to be a heap of questions on the build, the car, the configuration, the Nexus ECU, the keypad, the dash. There's so much in it. I do expect plenty of questions. If you guys want to leave them in the comments, we will be doing one more episode of this series, and I'll go through personally, answer all of those questions, address any of those sort of things that you're curious about, so that we can give you as much information as we possibly can. Like all of our build series, thanks so much for watching. We really, really appreciate you guys going all the way through to the end. My name is Scott, and I'll catch you next time.